Okay, so let's get back to this. What is this? Lowercase e. Okay. Lowercase e is a number called natural base number. It exists in nature, just like pi. It was discovered a few hundred years ago by a Swiss mathematician named Euler, if I pronounce his last name correctly. And in his honor, the symbol for the number is lowercase e. It's a number that is approximately 2.71 dot dot dot. It goes on forever. It never ends. But the good thing is, this is already programmed in any scientific calculator. So, if the number e is the base of your exponent, look at the number. Is that greater than 1 or less than 1? Well, it's 2.71, so that's greater than 1. So that means this is an exponential growth function. So again, you make a table, and 1, 0, -1 again, our beloved three numbers. What's e to the power of 1? Well, what's 2.71 to the power of 1? It's 2.71. What's e to the power of x? Anything to the power of x. Anything to the power of 0 is 1. So if x is 0 and you have e to the power of 0, it's 1. Doesn't matter. What's e to the power of -1? Well, that's when we use the calculator. Now, if you are using a graphing calculator like this one, or its application that I have already posted on Google Classroom, you can do an online application. If you look at this key, you see this one, ln, right above it, it's e to the power of x. So if you want to do e to the power of -1, well, obviously you have to turn that on first. I hope you can see it, yes. So you do second ln, so you get e to the power of -1, close it, and voila, 0.368 or approximately 0.37. So e to the power of -1 is 0.37. Okay, so here we go. Now, where is the asymptote? Well, I don't see a number after this. Plus or minus is just 0, so that means the asymptote is again the y-axis. What's the equation of it? Y equals to 0. 1. So if it's 1 and 2.7, so this is 1, 2, 3, so 2.5 is about here. So 2.7 is somewhere on there. Again, there's some estimation involved, which is okay. 0 and 1, and -1 and 0.37. Now 0.37 is less than 0.5, so that's halfway. 0.5, 0.37 is very close to the x-axis. So again, I'm going to draw very closely to the x-axis, but I'm not going to touch or cross it. And remember, don't pick up the graph going up like this. It's just like that. Okay, so what are the important features? We got the graph, we got the equation of the asymptote, we put the y-intercept, which happens to be 0 and 1, and it's growth. Okay, we're good. All right, very nice. 3 more problems and we are done, ladies and gentlemen. All right, now let's take a look at these problems. You see 8, 9, and 10. Now these are the opposite. For problems 1 through 7, we were supposed to graph each of them. But for problems 8, 9, and 10, the graphs are given to you. What do we have to do? Write the equation of the graph. So we're going backwards. We have the graph, we have to write the equation. Okay, so let me put this right next to this one. Look at the graph. Let me zoom in a little bit. Okay, look at the graph right here, correct? Okay, so is it growth or decay? Well, we know it's going up that way. So if it goes up that way, it's exponential growth. So we know that. We know the general equation is y equals ab to the power of x. Now, look, it's coming very close to the x-axis. So that means the x-axis is the asymptote. So what's the equation of the x-axis? Y equals to 0. So there is no other asymptote other than 0 here, a value. So there is no plus. You don't have to show it. So it's right there. I mean, if you want to, you can do this, y equals to 0, but that's irrelevant. Okay, so our strategy is first use the y-intercept that is given to you. Okay, so the y-intercept is 0 and 1. So this is your x, this is your y. Plug it in. So y is 1, I put it in place of y, and then I don't know what a is, I don't know what b is. That's what I'm looking for, because once I know these, then I can write the equation. But I know what x is 0. Okay, what's b to the 0? What's anything to the power of 0? Anything to the power of 0 is 1. So that means this whole quantity becomes 1. So you got a times 1. What's a times 1? It's a. So what does a equal to now? A equals to 1. Hallelujah. We got a. So now I'm going to rewrite the equation. Now the equation is y equals to 1, which is my a, which I don't have to show, but I'm going to show it anyways. B to the power of x. I still don't know what b is. Okay. So how do I find b? That's when we use the other point given to me, 1 and 2. So my y value is 2, so I put it right there. My x value is 1, so I put it right there. So I'm going to put it there. You see the x is 1. Okay, so what's b to the 1? B. What's b times 1? B. So b equals to 2, or 2 equals to b. So I found my a and I found my b. So what is the equation of the graph? Y equals to, now since a is 1, I'm not going to show it, so I'm just going to write 2 to the power of x. B is 2. So there you go. That's the equation of the graph for number 8. Are we good? I hope so. All right. So then let's go to number 9. Number 9, we have, I hope you guys can see it, number 9. Okay, so again, we write the general equation, y equals ab to the power of x. But look, oh, we have this dashed line. What does that mean? That means the asymptote is over there. It's not y equals to 0. It says y equals to 1. It's a positive 1, right? So I'm going to put plus 1. So there's an asymptote other than 0. Okie dokie. Now, let's start again. What's my y-intercept? 0 and 2. So 2 is y. I don't know what a is. I don't know what b is. But I know my x is 0. Perfecto. All right. So what's b to the 0? Remember, order of operations. We do the exponent first. What's b to the 0? It's 1. So then you have 1 times a, which is a. Now how do I solve this for a? Very simply. Subtract 1 from both sides and voila. A equals 2 minus 1. So a is 1 again. Now it's not always 1. It's just a coincidence. Okay? So a is 1. Now how do I find my b? So I'm going to plug the a value into the equation. So 1 b to the x plus 1. Okay. What is the other point given to me? 1 and 3. So x is 1 and y is 3. Now solve for b. What's b to the 1? B. What's b times 1? B. So you get 3 equals to b plus 1. How do I solve for b? Subtract 1 again. And b turns out to be 3 minus 1, positive 2. And again, b has to be greater than 1, because look at the graph. It's exponential growth, right? It's exponential growth. So b has to be greater than 1, just like the number 8. So here's the equation. I have both a and b. Y equals, I don't have to show a because it's just 1. It's irrelevant. B is 2 to the power of x plus 1. So that's number 9. Are we good? I hope everybody is okay with it. Last problem. Let me do it up here. Last problem is, look at the graph. Woo, it's going down, it's going down. Exponential decay. What's the asymptote? It looks like it's the x-axis because it's very close to the x-axis. There's no dash line like number 9. So it must be the x-axis. So that means y equals to 0 for the equation of the asymptote. So therefore, I'm not going to put a plus or minus. I mean, I can put plus 0, but that doesn't do anything. So I'm just going to leave it off. All right, so what do we do first? Now, it's exponential decay. That means the b that I'm going to end up with has to be less than 1, between 0 and 1. If I get something else, then I have a boo-boo. Okay, so we always start with the y-intercept. So y is 1. A, I don't know what it is. B, I don't know what it is. But x is 0. Okay? So therefore, b to the 0, anything to the power of 0 is 1. 1 times a is a, so 1 equals a. So we found our a. Okay, rewrite the equation. Y equals 1, and you don't have to show it. I don't know what b is, to the power of x. Now we use the other point, -1 and 2. So my y is 2, and x is -1. Okay. If you have a negative exponent, how do we get rid of it? You flip it. So you get, let me get rid of this 1. It's not necessary to show it. So I'm just going to write this. This whole quantity goes to the denominator. That negative exponent becomes positive. Now how do I solve for b? Well, you can say Wakanda forever. You can cross multiply, you have a proportion. That's one way of doing it. So 2 times b is 2b, or not to be, ha ha ha, and 1 times 1 is 1. So 2 times b, 1 times 1, cross multiply. So then how do I solve for b? Divide by 2, because 2 is being multiplied, the 2's are gone, so b is 1/2. Ha! Is b less than 1? Is b, oops, sorry, you're not seeing it, I apologize, I'm getting used to using this camera. So you see, I divided by 2, both sides. Let me review again. So 2 times b is 2b, 1 times 1 is 1. Then I want to get b by itself. Since 2 is being multiplied by b, I'm going to do the opposite. Divide both sides by 2. The 2's cancel out. b turns out to be 1/2. Is 1/2 between 0 and 1? Yes. So that means we have exponential decay. And if you look at the graph, yes, we do. It's exponential decay. So therefore, we have b equals 1/2. So now you can write the equation. Y equals a is 1, which I don't have to show. B is 1/2 to the power of x. There you go. You got the equation of the graph. So ladies and gentlemen, now we are done with all the problems in review A. Make sure you write them again. You only have to do the front side like before. And then please do growth and decay B, only the front side. But please make sure you do it nice and clean in pencil so I can see it when you upload it to Google Classroom. If it's written in some kind of a funky color pen that I cannot see, or if you write with a pencil but it's very light, then it's difficult to read and grade. So if you want to write in pen, it's okay, but make sure it's not messy. It's very legible, organized, clean. That's what I want from my seniors. Okay? So that ends the lesson for exponential growth and decay. These 2 pages will be due at the end of the week, and I'll post an announcement when it is due again, and I will upload this packet so you can either print it or you can just do the problems on a separate piece of paper. And if you do the problems on a separate piece of paper, make sure they're nice and clean. All right, hope to see you guys soon. Love you guys, miss you guys. This is Mr. E signing out. Goodbye.